When it comes to future-proofing the grid, what is driving utility planning? Is it climate change, influx of DER, data centers, or all of the above? Navigating the complex and dynamic changes to the grid and how this impacts the Goldilocks Zone so that we achieve what is just right will be discussed, along with a whole lot more on today's episode of Power Perspectives. I'm Jason Price, coming to you from New York City, and joining me as always is Matt Chester, podcast producer and community manager for Energy Central from Orlando, Florida. Matt, what are the pressing questions in this topic area you're hearing from the discussions at energycentral.com?
Thanks, Jason. Yeah, across our Energy Central community, we see utility leaders grappling with a convergence of challenges. Climate change driving more extreme weather events that stress the grid, the rapid growth of distributed energy and how that reshapes traditional power flows, and the surge in energy-hungry data centers that are creating new demand pressures. The big questions being debated on a daily basis by our community members surrounding this, they include things like, how are we going to modernize infrastructure? How are we going to maintain reliability? How do we fairly compensate distributed resources? How do we ensure regulatory frameworks keep pace with these shifts? And I think ultimately utilities are looking for ways to balance resilience, flexibility, and affordability while steering the grid towards a more sustainable, future-proof model. And, as we all know, there doesn't seem to be a silver bullet solution at this time.
Thanks, Matt. And before we dive into today's episode, I want to thank Siemens, our sponsor of today's show. And today's conversation will hopefully tee up some of those answers to the questions Matt suggested. As for this episode of Power Perspectives, we're joined by Marcus McCarthy, Senior Vice President of Siemens Grid Software for the U.S. and Mexico. Coming to the conversation with a wealth of experience leading both hardware and software technology businesses, Marcus specializes in developing growth strategies in his role at Siemens. And Marcus and his team are helping utilities navigate a rapidly evolving energy market, fostering innovation while addressing critical challenges. So, Marcus McCarthy, welcome to Power Perspectives.
Thanks, Jason. It's an honor to be here. I'm a big fan of the podcast.
We appreciate that. We appreciate you taking time today to talk to us. Marcus, before we dive into the topic at hand, I want to give you a chance to share a bit more about your role in the utility sector. So what exactly does the SVP of Grid Software at Siemens do, and how do you interact with the utilities?
Thanks, Jason. So on the Siemens Grid Software business, we focus on developing software products for utilities, as the name would suggest. So we have a broad range of software products targeted at all segments of the utility industry. So for example, from a market operator point of view, we have software or market management software that forecasts energy demand, looks at the energy bids coming into the marketplace and decides what electricity should be supplied where on the market. And that's interesting software because it does this in a way that generates an optimal outcome, taking into account a large number of constraints and objectives that are often in conflict with each other, such as minimizing price, reducing carbon emissions, ensuring reliability of supply. So the system does this for a day ahead, an hour ahead, and it does it actually in real time as well. So interesting solution. In the ISO TSO area, we have our energy management system, Spectrum Power 7. So that allows transmission utilities to monitor the network, to understand what's happening in real time and then operate the network in response to what's happening on the network. We also supply, I guess, the industry leading range of simulation and planning software for transmission networks that allows transmission grids to plan extensions and changes and everything that's happening there at the moment. Quite a topical area right now. On the distribution network side, we have Gridscale X meter data management, important market leading software for managing meter data within the utility, which used to be a billing issue only. Nowadays, the meters are very, very important in terms of data that's used in a lot of different ways on the network with regard to DERs. And we also have Gridscale X Grid Model Builder and DER Insights. So software to improve the digital twin of the distribution network and also to help to manage DERs and understand the impacts of behind the meter DERs on the network overall as they're deployed. We have a microgrid management system, which allows an operator or owner of a microgrid to optimally operate that microgrid with batteries, with different generating sources and deciding when to connect to to the grid or disconnect from the grid. And then we have a whole consulting business that helps utilities mainly to do power system planning, business strategy, optimize business processes, and do a lot of training, a lot of PhDs in that business. So I spend my time working across all these aspects of the business, spending a lot of time with customers, and translating their thoughts, their problems into solutions within our business.
Okay. All right. That's very helpful. So let's talk big picture here. And I feel like this is a question we ask a lot of our guests, so bear with me. But basically, the rise of DER, distributed energy resources, has created both opportunities and challenges for utilities. So what do you see, as Siemens, what do you see as the most pressing issue when it comes to integrating DERs in today's grid?
Yeah. So it's a topic I think that's continuing to be a conversation, ongoing conversation every day. Harnessing the potential of DERs as an asset for grid flexibility, and while scaling customer satisfaction. It's quite a challenging change to networks. Some of the issues that we work with on a daily basis, the whole area of permitting, planning, prioritizing, and executing network upgrades to enable the interconnection of grid scale DERs is obviously a major challenge. We don't have the network to move sufficient energy from where it's being generated to where it's needed today. With long interconnection queues, and our planning software is being used to speed up that process, to optimize that process. When trying to operate DERs as part of the grid, we're really changing from a few power supply areas on the grid to a large number of potential power supply areas. And that creates a whole lot of competing priorities in terms of managing voltage and frequency on the network. And that's an ongoing issue that we're making our way through. And then I think maintaining stability with inverter-based DER resources on the network is an ongoing issue for NERC are continuing to look at issuing regulations in that area on our network. And then on the distribution grid, as we deploy behind the meter DERs, the distribution grid was never designed to operate with these type of loads on distribution transformers, and understanding those DERs and how they're impacting the network, and planning for that, and planning for the future of distribution grids where you may have two-way flows and islanding and other aspects like that.
I want to ask you about DERs. It's basically a technology. It's not just a concept. It's technologies, and it's a portfolio of technologies that have been around for quite some time. I mean, it's been, at least 2 decades. I studied DERs when I was in school. So, why does it continue to be such a pressing challenge for utilities today?
I think there's 2 reasons. I think it's based on volume and public expectations. If you take historically, it wasn't an issue because the volume was low and we could continue operating networks as we did previously. It wasn't really impactful on the network. And historically, the public wasn't really mindful or overly involved. I think what we see today is that the number of DERs is increasing. And I mean that across the network, at grid scale, at transmission, in front of the meter and behind the meter, we're seeing a proliferation of DERs. And I think the impacts of those DERs then and the opportunities associated with those DERs are starting to be realized. And there is either an oh moment and also a how can we use this moment happening at the same time? And it's all related to the volume. And in utilities, we operate for reliability. We operate for economic supply. And this is opening up a whole lot of opportunities to have different ways of operating networks. And then there's a public interest in DERs. A lot of people really care about the future of the planet and are doing their best to participate in reducing carbon emissions. And I think the public interest in DERs is part of the reason that they're becoming such an important part of the conversation today.
That's helpful. Switching topics for a second, I want to talk to you about data centers. And I know you've got your perspective, and Siemens is doing a lot across the spectrum of energy and power, and data centers is a hot topic for you as it is for others. It's increasing the demand, both the data centers just in general and the power load that's required of them. So it's a very tricky area that we're all trying to figure out to some degree. When we refer to data centers, define for us what is meant by the Goldilocks Zone, and how is the trend of data centers in the Goldilocks Zone shaping conversations that you're having with utilities?
All right, interesting question. So there's lots of Goldilocks zones related to data centers because they're operating at the real edge of capability of technology in so many different ways. But I presume you're referring to the efforts within data center to match their energy needs in a perfect and non-wasteful manner while reducing carbon emissions and optimizing economic benefits. So this whole kind of trade-off, this optimization across multiple factors that are often in conflict with each other, and then trying to get that mix just right is we're kind of talking about in terms of the Goldilocks zone. And it really is about solving a problem of optimizing a long list of competing objectives with different constraints among those objectives. For example, at a data center, I could be operating my own microgrid and have a grid connection. So I might have a solar combined generator battery capability. And then I need to decide in advance how I want to optimize the operation of those assets to minimize the cost, minimize the carbon footprint, while safely and securely providing sufficient electricity for what the future demand of the data center is for the next 24 hours. And then I might also want to bid some of that capacity into the market if I have it as well to optimize my solution economically. So if you think of all of these constraining, competing objectives, it's a very difficult thing to do. And I guess that's why they're calling it the Goldilocks zone. And then on top of that, your transmission system operator may also want to know what your forecasts are and may want some element of control or participation in when you connect to the transmission grid or participate by providing electricity to the grid. So particularly complex area that we're working with a large number of data center providers on.
Good. Okay. Great context. So the next question is data centers and the intersection of data centers and the utilities. There's different models, there's different approaches. It's a fairly dynamic and in some respects fluid situation. What are some case studies that you have that perhaps you could share? Are there any common issues that arise or solutions that you've seen that are being adopted or not being adopted? Just, can you talk about that?
It's a really insightful question, and not a lot of people are aware of how difficult this interaction between the utility and the data center is. I think the area where we're seeing the biggest issue is in a lack of understanding of the constraints and objectives on both sides of the table. And we're seeing a lot of opportunity for our consulting business to sit in the middle there and to facilitate engagement between utilities and data centers in a particular area. We're also seeing increasing sophistication and increasing development of opportunities for the data center operator to help the utility in what they're trying to achieve. And then the utility needs to understand the commercial objectives of the data center as well. So it's an integration, collaboration, communication problem. The technology to do that is all there. It's just a matter of everybody getting around the table and understanding what the objectives and constraints are.
Okay. Thank you for that. Let's talk about, some other areas that I think Siemens is in. It's really around the grid of the future and the role of AI and autonomous system. I believe you have product lines and support and you provide some advisory in this area. I'd love to hear, how are you advising utility partners approach AI, the use of AI and drive grid mod? Just what are those conversations like and how are you approaching them?
Yeah, so there's quite a number of areas where we are deploying AI today and discussing, opportunities with customers to deploy AI to help them to optimize what they're doing on a daily basis. So take, for example, a utility planning department, right? One of the roles in planning is to do contingency analysis, to understand, given these contingencies, what the risk might be and to develop plans ahead of time on how the utility might react to those risks when they happen. So in traditional mode, a planner might, analyze and perform plans, create plans for maybe 5 or 6 contingencies in one day historically. But via the use of AI, the AI can analyze hundreds of thousands of potential contingencies on the network, look at what the options might be for those plans, and then suggest where the planner might spend their time focusing, because these are the highest risk contingencies for the network going forward. So it's really an assistant that does a lot of data analysis, understanding context, and helps the planner to do their work better in more volume. And that's really, I think, part of what we see with AI is that it is a partner to a planner in that regard. And in other areas, for instance, when there's a problem on the network, AI can very, very quickly look at the current operation of the network, look at what the options are for restoring supply, look at whether that's safe in a power flow analysis point of view, and can give the operator, for instance, a list of options, but also then tell the operator, what the upside and downside of those options are in terms of, optimally restoring the maximum number of people and what the potential cost of that might be, as opposed to a different approach. So again, it's helping the operator to get to the data that they need more quickly. And I think that's the pattern we're seeing with AI. Is it's not a complete solution on its own. It works with the utility to optimize solutions.
Without naming names, not put you on the hot spot here, but AI and its interactions and uses with utilities can be a major transformation. Do you have any concrete cases that you could share to just show the power and extent and range that what you're seeing out there in the field?
One of the areas that I think is really, really interesting is in operating a marketplace, for instance. AI is very, very useful in terms of learning what power may be generated based on the weather forecast for the day before from photovoltaic. It's actually really, really complex to do that reliably across a large number of PV installations. And it's not just the forecast, it's the cloud cover. And it's doing it a day ahead, but then doing it in real time, depending on the conditions that show up on the day, and depending on where, for instance, cloud cover might be with regard to large solar farms that sit out there, and how are they going to be impacted. So AI can do a really, really good job of taking a lot of historic data and using it to learn and to forecast better going forward. And we have software in production today that very, very accurately uses real-time data on cloud cover and sunshine, et cetera, to better forecast what energy is going to be available in real time from PV. And again, I gave you the example a while ago where we're using AI to suggest switching operations on a network, the different solutions that might be available, and to help the utility get to this sort of a semi-autonomous network management, which helps them to optimize the whatever their objective is for operating the network. So again, I think with all of these things, we're seeing a lot of them as a two expert system. The AI is helping to prepare data to learn, and then the operator is making the final decision based on the context that they have at that point in time. So we don't really see it as a machine making decisions automatically. It really is a two expert system.
That's a great way to frame it. So thank you, Marcus. I think that's an interesting way to look at it. It makes complete sense. All right. So this is a question, it can be Siemens or it can be more broad. And that is, what are some areas, if you're looking into your crystal ball, or utility leaders looking into their crystal ball, what should they be thinking about tomorrow? What are perhaps some trends or areas of focus that we should be preparing for?
Okay. I think for ISOs and TSOs, they need to continue preparing for increased volume of generating sources with inverter-based connections to the network, alongside intermittent loads from microgrids. I think that's something that we're going to see more of, as microgrids related to buildings, to data centers, to other facilities that will have their own ability to serve themselves at times. And those two topics are interrelated as well. So the microgrid and the increased IBR, inverter based DERs, on the network. Those are going to continue to add complexity, continue to add dependencies that we haven't seen before in terms of the traditional operation of transmission networks. On the distribution side, historically, if you asked everybody on the distribution side of the network, they would have, and the policy was to operate the network to failure. Energy was traveling in one direction on the network, and historically we operated distribution networks to failure on equipment. I think as the operation of that network becomes more complex, as the number of DERs on the network increase, I think the complexity of operating that network will increase, and improving the quality of the digital twin of the distribution network is a challenge that we will face, and that we need to put more time and effort into, because only by having a good model of the network as it operates can we optimally include these DERs in how we operate the network. So it's getting the model right for the distribution side, and I think we have a lot of effort to put in there, because the level of data and sophistication of that model will need to increase as we try to do more with distribution networks.
Yeah, that'll be key to maintain the stability, no doubt. Really helpful, and you said you've listened to the podcast in the past, so you know that we have something called lightning round, which is where we are now. So
Okay.
we'll give you the final word, an opportunity to have the final word. But for now, we're going to throw a bunch of questions at you. And we ask you to keep your response to one word or phrase.
Okay.
So are you ready?
Okay.
All right, here we go. What time of day do you get your best work done?
During my workout or immediately afterwards. So before all the phone calls and meetings start, when I get a little bit of time to spend some time inside my head and think.
What's your favorite city you've traveled to?
I guess Rome in Italy. I could just spend days walking around Rome. There's something fantastic. Every time you turn around a corner, there's something terrific to see, and you can stop and eat anywhere. So yeah, Rome would be one of my favorites.
Here's a Goldilocks related question. When it comes to cuisine, do you like it not too spicy, or just right?
Too spicy. I love spicy food. I often think food is more enjoyable when there isn't so much spice in it, but I always go too spicy. There's something addictive about it.
What's one word that sums up the future of energy?
Interesting. For such a long time, for anybody who's been in the industry for quite a while, it was a very quietly moving forward, methodical industry for so long. And now there's just so much happening, so much challenge, so much innovation. It's really, really interesting. That's what it is. Really interesting, and a really fun industry to be in at the moment.
We've been collecting lightning round questions from past podcast guests. So I'm going to ask you the same question in a moment, but the question from Mike Goggins of SSP, who joined the show recently, he left the following question, which you're going to answer. And that is, what one decision do you make that changed the direction of your career?
On two separate occasions during my career, I stepped out of corporate life to go to do a startup myself one time, and I bought a company that I owned and operated for a while. And as I say, I've stepped in and out of different corporate elements of my career. I think owning my own business has helped me have a very different perspective on what business is about on a day-to-day basis. So I think that decision to step out and do my own thing was very, very formative.
All right, now it's your turn. What lightning round question do you want to challenge a future guest? And Marcus, it can be a related topic to energy, or it can be an off-the-wall question.
It's maybe a little bit off the wall, but it's about people. So the question I'd like to pass forward is, because I like to learn from people. How do you help those around you to be better every day? How do you help people to reach their true potential?
That's a great question. So we'll ask that from future guests. All right. So I told you you'd get the final word. So knowing that you've got a utility audience listening in today, what's some advice you'd want to share? What is some meaningful closing thoughts you'd like to share with them as they navigate through this complex and rapidly evolving landscape?
Mm-hmm. I'm not sure really I'm qualified to give advice, but I can talk about one thing that I'm observing in the marketplace today that is helping everybody to get the best outcomes and the best results. I think looking at the relationship between companies as a partnership, not really as a customer supplier relationship. What we're trying to do right now in terms of hardware and software systems and solutions is complex. If we can work as partners, we get so much further, so much faster, and get a better outcomes. My perception of how these relationships, when we work in a pure customer supplier relationship, it doesn't get us as far as working as partners. So I guess the thing that I would like to see is and I'm seeing it more and more, I think it's happening naturally, to be honest, is greater partnerships across the industry to optimize the outcome for everybody.
Excellent. Great closing thoughts. I think I would agree with much of what you've shared there. So thank you for that. And I implore our Energy Central listeners to share their follow-up questions and comments to this episode and share them with Marcus. And I'm sure Marcus will take time to respond back to them. And you know where you can find Marcus on the Energy Central platform as one of our contributors. So thank you again for taking time today to talk to us on the episode, Marcus.
Thank you.
And you can always reach him, as I mentioned, through the Energy Central platform, where he welcomes your questions and comments. We also want to give a shout out of thanks to the podcast sponsor that made today's episode possible. Thank you to Siemens. Siemens is leading the shift toward future-proof grid infrastructure with technologies that enhance efficiency, reliability, and sustainability. Siemens Grid software enables grid operators to accelerate and secure the energy transition in a sustainable and profitable way. The Grid software suite connects the physical and the digital world with an integrated OT and IT landscape along the entire value chain, from planning through operations to maintenance. As part of Siemens Accelerator, digital products help utilities accelerate digital transformation easier, faster, and at scale. And once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com, and we'll see you next time at Energy Central's Power Perspectives podcast.